So, hello everyone. So, welcome to the ARMS. And this is my pleasure to standing here. You can see that this talk is about the satellites. And the title is Birdman. So why do I call myself the Birdman? That's very interesting. Because the satellite is flying in the air. So you can see that one like a bird, isn't it? So if someone want to hack it or want to receive the data from the satellite, they will become the Birdman. So I call myself the Birdman. And and first, I want to talk about me. My name is Jingli. I'm from 360 Technology Company, which is the biggest company in China. So I'm a researcher of the Security Research Institute and a member of Unicorn team. Maybe you have heard about my team. My team is very strong in the IoT research. So I'm a radio amateur and a space lover. My job is research the security of the satellite communication, so I always need to receive signals from the satellites, like the weather satellite and so on. So you can see that I'm always working outside and take a lot of instruments. That's very cool, isn't it? So if you want to receive the satellite, the antenna is very important. You need a high gain antenna, and to do that, because the satellite signal is very, very weak, and the LNA need a very good tool. By the way, you need a lot of knowledge to help you to do that. Computer knowledge and wireless knowledge and electronic, that's very important. A lot of people want to hack the satellite, just need a net line. So that's so funny. Satellite is too complex, and the satellite control link is different from the data link. So if you want to hack the satellite, you need to send signals to the air. And here are some common tools of my useful. So the software like the GNU Radio, software SDR console and SDR shop, and like the GQRX on the Linux, the hardware like the LSPI, Proto SDR, USRP, and blah, blah, blah. So you know that they have a lot of good SDRs in the world. And if you want to receive signals, you can use the LSPI. That's a very good SDR for the receiver. And if you need to send signals, you need Proto SDR or USRP. I like the Proto SDR very much. So thanks to the ADI company, they give us a very cheap SDR to study and research. So satellites have a different orbit around the Earth, like the LEO, MEO, GEO. So of course, they have another orbits like the GTO, IGSO, SSO. The LEO satellite is more near than any other satellite. So, but the LEO satellite is flying very fast, almost 7 kilometers per second. So look at the picture. The LEO satellite is very faster than GEO satellite. So that's not easy to capture the LEO satellite. So we need a precise clock to help me to capture, like the GPS time service and an auto tracking antenna. The TLE file can be downloaded by the NORAD. That's a very interesting organization. So, and the TLE data can be used for tracking the satellite by the module of SGP4, SGP4, or SGP8. So the SGP4 module always working for the less than 225 minutes over time. So if you want to learn more about this, you need to Google it and by yourself. They have a lot of knowledge about this. So how to catch the LEO orbit satellites? The LEO satellites often flying very fast, and if you want to receive the data from them, you need a good antenna. and your antenna need auto tracking to the satellite. So I'm building an auto tracking system named OpenATS. That's very cool. The OpenATS can help me to the tracking the flying satellites. Of course, if you want to build in your tracking system, you can download it, the OpenATS from the GitHub. That's an open source project, and you can replace the antenna to a gun. That will become an auto fire system. That's a joke. Don't tell anyone I said that, okay? So my antenna gain on the L band is 16 dBi, and the LNA gain is 15 dB, and the LA loss factor is 0.7 dB, and my antenna diameter is 0.9 meter. So that's a very good LNA. See the picture, computer sends the signal to the OpenATS, and the OpenATS controls the antenna to point the satellite. So, look at that video. You can see my auto tracking antenna, and just give them two angles like the AZ and the EL. He will point the target. You can use it to tracking the satellite or any other flying device. But you need building this by yourself. I use a ship antenna to do that. So OpenATS is running on the Arduino board to control the step motor. So someday when I was using my OpenATS to search the satellite, I found something on Euro. I found some analog signal from on my spectral software, and this signal with the Doppler shift. When I decode it, I can hear someone is talking. So the signal center frequency is 1544.5. So wow, that's very unbelievable. So people always talking on the UHF or VHF band, the interphone working on this band too. So but this is in L band. So what is in L band? L band always using for the airplane and the satellite communications. That's very important band. For example, the mobile communication with the satellites and GNSS system, and the signal with the Doppler shift. You know that the Doppler shift, blue shift or red shift. So I think it's from the moving device. So I need to find out where is the signal from, and I Google it. I found that's very interesting. And I found out the system named Cospas-Sarsat, and the system's downlink have a center frequency in 1544.5 megahertz, and the signal was from the NOAA-18 satellites. NOAA weather satellites made by Americans. That's very important weather satellites in the world. And many countries to get the weather information by the NOAA satellites, like the NOAA 15, 18, 19, 20. The NOAA 20 have another name, GPS-S1. So they are LU orbit satellites. You can see that a lot of pictures from the NOAA satellites. Somebody maybe try to receive them, like the APT picture or HRPT picture. Look at this video from the NOAA satellites. You can see that the signal from the NOAA satellite downlink have a center frequency on the 1544.5 megahertz. the signal is more and more stronger. So you can see that a lot of analog signals from the AOA satellites Okay, so you can hear that someone is talking. So what is a Cospas-Sarsat? And why the weather satellite have a word single? And I don't understand, so let's go on. The Cospas-Sarsat is a search and rescue satellite added tracking system. So, and the first satellite, Cospas-1, launched in 1982, and the four original member nations is the Soviet Union, US, Canada, and France. So, this is the principle of the Cospas-Sarsat system. We can see that the emergency meetings, the number one emergency meetings in the signal to the satellite use 406 megahertz, and the number two is the search and rescue satellites. And the number two, the satellite receives the signal and replay to the number three, the local user terminal. Local user terminal is the LUT ground station. So use the downlink is 1544 to 1844 to 1844.5. So the number three, the local user terminal ground station decodes the message to the number four missing control center, and the number four receives the message and let the number five rescue team to give help. So you can see that this system is a rescue system. That's very cool because the system is very important to save people's life. And look at the emergency beacons have three different terminals. One is ELT for the airplane and a helicopter. So one is PLT for some people or some team. So another one is EPIRB for the ship. They have a GPS module in the beacons, so the message will send the GPS position to the MCC control center. So that is very important. And first, they have no GPS module in the world beacons, in the old beacons. But we can calculation where the signal from, because we can know that the satellite's position and the Doppler shift of the signal. Then we can calculation the concise angle of the beacon. So this system have 94 LUT local user terminal stations and more than 34 missing control centers in the world. You can see that the tracking antenna in the LUT station, and the antenna receives a signal from LU or MU orbit satellites, and a lot of MCC control center in the world, always on the seaside, because we need to receive the message from the sea. If we have more and more stations, we will not miss any beacon. They have a big antenna for the GEO satellites too. more bigger and not need tracking because the geo satellite is not moving from us, and the LUT stations is very important in this system. We need them to receive signals and decode the message to the satellite. They have more ground station is building now. So the Cospas-Sarsat payload always working on the weather satellites like the METOP-C, NOAA, Fengyun satellites. This payload is not easy to take it because the payload is very impulsive and need good antenna and more power. The power model satellite is very valuable, so this payload always working on the big satellites like the weather satellite, communication satellites. So we need a lot of satellites to cover the whole world. That's very difficult. And this system support more than 41,000 rescues, more than 35,000 lives, and have been saved in the world. And this service have a wide range of applications in the world. So this is a great system. If you can't connect your friend or 911, you can use this system only. The beacon can save your life. So if you want to go outdoors, maybe you need to take one PLB for you. So look at this video. This video is from the NOAA. They have something wrong with the ship. The people need help now. They are send a message to the Sarsat beacon by the Sarsat beacon and send the message to the Sarsat satellite, and we know that where we are, where they are. Okay, so what is the contact of the distress signal? So let's go into analyze this system and find more interesting things about this system. And number one, found the protocol of the Sarsat system from the official documents. In the official documents, I found the spectrum of the beacon signal and the format of the message. The message have two different formats, short message and long message. So they have country code in the message. That's why we can know that which country the ship or airplane from. And they have GPS data in the 37 to 85 bits. And at the end of message, they have BCH code to make sure the message is right. So BCH code is an error correction code. So get the information from all the system. We can see that the system modulation is single modulation is BPSK, and the symbol rate is 400 BPS, and the bandwidth is 18 kilohertz, and the uplink power is 35 to 39 dBm, like the 3 to 8 watt. So the uplink frequency is 406 megahertz, and so on. And the downlink frequency like the 1544.5, like the NOAA, GOES, GPS, METOP, and 1541 Inmarsat, and 1544.1 like the Galileo, and 1544.9 megahertz like the GLONASS. And on the S-band, the GPS-3 and the DSS satellite, and the C-band inside the satellite. So look at the top of the picture. The signal received by the 406 megahertz antenna amplified by the LNA input unit and go to the down converter, and then the LO signal output and go to the converter up converter and to the L band to the output the power amplifier, and the next send out by the L band antenna. We can know that the payload don't do anything, so just up counter the signal to the L band. So that's very interesting. I found that the payload have two different channels. One is SARR and another one is SARP. So the SARR is just a repeater. The analog signal and interference be received by this channel. The SARP can decode the message and send to the LUT station. But the SARP payload just can handle 2400 bits, one pairs 1 second. So the beginning signal is transmitted by the remulsion, and the SAR is do nothing for the signal, just a rescue repeater. So the signal from the interphone be received by the SAR payload and the up converter to the L band downlink. That's why I can hear someone is talking in the L band. That's from the SAR payload downlink. And you can see that the NOAA is downlink frequency and the spectrum, and from the Inmarsat F3 satellite. And the right, you can see the beacon is like a bird, so it's too small. I decode the message by the EPIRB plotter and the Multi PSK software. Of course, you can buy another way to like the GNU Radio or MATLAB. So I decode it from the Inmarsat F3 satellite and look at the message. One ship is from the UK, and another one is from the France. They are dangerous and they need help. If you want to receive and decode the message, you need an L-band antenna and flatter. Then input the LNA and to SDR like the SBY. Then they can use the software decode the SARR message. By the way, you need to find where is the satellite. So look at this video. I'm using my antenna to receive the signal from the NOAA 1918 and use the Multi PSK software to decode the message. We can see that a lot of analog signals from the downlink, and the beginning signal is very small, like a bird. Okay, so we decode the ship is from the Japan, and it's in dangerous, need help in the sea. So this is all the Sarsat satellites. They have weather satellites, navigation satellites, and communication satellites. So like the GOES, GPS, Galileo, GLONASS, and Fengyun, and Inmarsat, Inset, Electro L, and the NOAA, Meetop, NOPOS, and Beidou, DSS, and so on. So they have more than 2 million users in the world, and more than 37 satellites online now, and more than 94 LUT, local user terminal stations, and more than 34 MCC control centers. So that's a very big system. So let's do a load practice. Okay, I'm building a project for the test. So I'm building a software named Hexa, and to do some interesting things, the Hexa sends a message to the GNU radio, and the GNU radio modulation this message and send it to the SDR. Then the SDR sends the signal to the air. And the receive side, I use the LSPI to receive the signal and decode by multi-PSK. The software can send the text message or a lot of message to attack the Sarsat system across UCAN communication by satellite too. So it's very dangerous. Exactly, the GNU radio project is not the real project. I'm sorry, I can't open the series, the software, and the GNU radio project. So I don't want anyone use it to attack the Sarsat system. So that's well not funny. Look at this video. I use my software to send a lot of false message. I use the Proto SDR to do that, and receive the signal by the LSPI. So you can see that the software sends in the DDoS mode and send to the SDR. And I use the multi-PSK to decode the message. A lot of false message in the software will become so all of these are false message. Just DDoS the system. Okay. So if someone sends a fake rescue message to the satellite, and the MCC control center will be receive the false message, then let the rescue team to give help. Okay, so don't worry about this. I tried the test in the legal frequency. So they can search the message by them data center, but we can receive the message from the satellite downlink, and we can use that message as the serial of attack. So they can't make sure which one is real and which one is false message. And how to build a transmit system and receive system? The number one, you need a PC to build the message, and then you need a SDR to send the signal like the number 2. And number 3, use the UHF band amplifier and output the signal to the antenna. And the receive side, you need antenna working on the L band and connect to the L band LNA, and then input the receive SDR, like the LSPI, and go to the PC to decode the message. So what impact does this vulnerability have? If some hacker send a lot of false message to the satellite, he will attack all of the Sarsat system in the world because all of the MCC control centers are interconnected. For example, if some ship from the America is dangerous in China, and and then the MCC control center in America will know that the member country will help each other in the world. The question is, MCC center can't make sure that which one is true and which one is false. So they will not care about the people who need real help, and time is life if you are in dangerous. So that's very dangerous. Look at this picture. If someone send a message by the satellite, for example, send a message A, the number A, the A send a message to the number B. That's very interesting. Look at this machine. Maybe this interphone have a spy mode. Another mode is the spy mode, and one mode is the interphone mode. So maybe input the 007 will be input the spy mode. So when you input the spy mode, the information can send the message to the satellite and decode to the another way, decode to the other side in other countries. Oh, okay. There's something wrong with. You can see that this is all of the 67 satellites in the air. So too much silent to make sure not missing every beacon. The right picture is the coverage area of the LEO and the GEO satellites. You can see that the GEO satellites have a wide range of area. So see the point of A, B, C, D, E. The NOA 18 is LEO satellite, and the Electro L2 is satellite is the GEO satellite. If A send a message to the L2 satellite, the C can receive that too. So if the B send a message to the NOA 18 satellite, and the E will be receive it. And if the B send a message hello to the satellite, and the D will be receive that and in the Australia. So you can use your self-modulation and encryption. Nobody knows that what you send. So maybe spy already using it. Okay, if someone send a lot of fake message, and that will be too bad. The MCC control center will get a lot of false message and can't do anything at that moment. Of course, if the hacker send a long time, they will find out where is the hacker. Don't do that. The hacker also can stealing the satellite links, and that's the hacker's favorite. Maybe it's yours, but please don't do that. So the Sarsat payload is very sensitive. So, but much of interphones have high transmit power. I did a simple calculation. The AOA satellite, the free space loss at the 406 megahertz will more than 143 dB, but the intercom's transmit power is too high, easy to interfere the satellite by the blocking so interference. So the satellite will not normal to receive the real beacons at that moment. So, and if someone send a single more than muse 16.16 dBm, then will be received by the satellite too. Exactly, this is the menu value. So the satellite payload is easy to be interfered in the worldwide. So they have some questions, there are some problem. The number one is anyone can receive the decoded message through the L-band antenna, and the satellite payload is to sensitivity, very easy to interfere and DDoS attacks. So everyone can send the false message to the satellite, and the satellite link can be stolen. So I found a lot of interfere in the satellite downlink. That's very unbelievable. We don't know about this before. Look at this. My friend helped me to record some signals from the Australia and England. We can see that the same problem also in these countries. I think the same is true in the whole world. So maybe they didn't know that they are interfering in this system, and they send the signal and the 406 megahertz. Maybe they never heard about the Cospas-Sarsat system. But it is only illegal to transmit information at 406 megahertz. So that's very important. Most interphones can be sent and received at 470 megahertz. That's why so many interference can be found in the downlink of the satellite. And that's very important. If you are a ham, you will know that a lot of interphone can be working on the 400 and 470 megahertz frequency. So that's very important because a lot of people don't know that they are interfere this system. So if you attack this system, maybe you are killing some people. Then you will become a modeler. And please do not interfere this system. We need this system to save more and more people. They are saving our lives. So maybe somewhere you will need to save your life, and don't do that, please. Okay, so thank you, my friend from the England and Sam from the Australia. So, any questions?
Yes, thank you, Hao Jingli. Thank you for your presentation. Are there any questions? Yes, I'll come over.
So how wide was the band that is being upconverted by these satellites?
Like the 18 kilohertz. Okay, so the wide is very big wide range. So you can use it to send your message or voice to talk each other by the satellite.
Okay.
Any other questions?
Is there any initiative to add device authentication or some sort of cryptographic signatures to allow device manufacturers to sign the messages that they're sending?
I'm sorry, I don't know what you mean. Can you say it again?
So the denial of service attack problem comes that there's no authentication on the messages that you can generate just the bit stream and send it, and they don't know if it came from an authentic ELT or some device that you've manufactured. Do you know if there's any movement or any initiative inside the industry to try to add an authentication layer to the messages?
Yeah, but if you send your message by yourself and with your modulation and encryption, so anyone can't know that what you send.
Right, so that works in the case where you're flooding it with other messages, but in terms of the sending fake distress messages. That
I'm sorry, I can't know what you say. I don't know what you mean.
So, are there any other questions?
Yeah, I've got the mic here. In the case of spies using the system, I'm over here, by the way. It's possible for you to see the beacons that are being transmitted by the spies. It's just that presumably the message won't be interpreted as a proper distress beacon because it's containing some other information that they want to send to somebody else. Would you be able to locate the person sending a message like that through the system?
Yeah. So sorry, my English is not good, so I don't know what you mean.
So you gave the example of spies using the system to send messages.
Yeah.
Everyone who has access to this system can see all the messages sent via it, right?
Yeah.
So if a spy tried to do that, would they be able to disguise it like a legitimate beacon, or would it be obvious that they were using it to send information that wasn't supposed to be sent via the system?
No, if the spy send the message to satellite, you can use the SAR payload, and the SAR payload not care what is the message and what is the signal. So the SAR channel just replay to the signal to the L-band downlink.
Mm-hmm.
So if you send a message by your modulation and you send any angles, so the satellite don't do anything, just replay this signal to the downlink. So you can send any message, not only in the beacon.
Mm-hmm. And would it be feasible for the owners of the satellites to locate people that were using the satellites in this way?
Yeah.
Okay.
Okay.
Thanks.
So, anybody has a question still? No? Then I want to thank him very much for his talk.
Okay. Thank you.